MCCB is a required component of electrical systems, providing overload protection and short-circuit protection. In most cases, MCCBs are installed in the main power distribution board of a facility, allowing the system to be easily shut down when necessary. MCCBs are available in various sizes and ratings, depending on the size of the electrical system. In this guide, we'll cover the components and features of a typical MCCB, how they work, and which types are available. We'll also discuss the benefits of using this type of breaker in your electrical system. What is a molded case circuit breaker? A molded case circuit breaker, or MCCB, is a safety device used to protect an electrical circuit from overload or short circuits. It works by automatically cutting off the power supply when a fault or overcurrent situation arises, thus preventing any damage to the electrical system. MCCBs can be used in both low-voltage and high-voltage systems. In addition to providing protection against faults, they also provide isolation of the circuit for maintenance. MCCBs are typically installed in the distribution panel and provide a visible indication to let users know when the power is off. The main components of an MCCB are: molding case. The molded case or frame is the cushion that keeps all parts of the circuit breaker in place. It is solidly built from glass polyester, or thermoset composite resin that gives a great non-conducting strength despite its compressed size. Terminals. The terminals serve as connectors between external conductors and molded cases. They should be connected properly to prevent unusual heat production. Operating apparatus. This is the switch that opens and closes the molded case. Its handle connects the pull of the device and manual push. Trip unit. The trip system is composed of temperature and current reactive electromagnetic sensors that trigger the operating apparatus in case of short circuit or current overloads. Its button can be pressed to reset the circuit breaker. Arc chamber. The arc extinguisher's primary role is to curb and split the arc that can damage your circuit breaker. The action results in exterminating the current flow in the circuit breaker. Inside the arc chamber are contacts. Their role is to conduct and disrupt functions. Arc runners, on the other hand, function as new electrodes for the arc. Arc chutes, on the other hand, compress the arc in the middle of sidewall insulators.